flexible it is in the sense of how much you allow it to wiggle to get close to the data. And so in a GAM, you basically, typically you look at you sort of look at the data and get a sense of, is this pretty much linear? Does it have, a quadratic type curve? Is it wiggle up and down? You can also put constraints on it as to whether it's monotonic or not. Okay, so you can sort of build all those qualitative aspects of the function without having to say, well, I'm going to use an exponential function, or I'm going to use a sinusoid, or you don't have to make those arbitrary choices. So that's kind of the regression approach. And then there's a machine learning approach. So what is machine learning? Machine learning is really, you can think of it as a black box. You've got a set of inputs, which are all your environment variables, and you've got an output, which is the predicted quality of or the likelihood of seeing the species given that environment. And then these are just kind of black box ways of building that relationship using different kinds of complex nonlinear relationships that often aren't even easy to express mathematically. And inside the black box, it does a whole bunch of optimization. Neural networks, we're talking about neural networks, right? So they're just the neural networks and genetic algorithms are sort of loosely based on thinking of layers of neurons in the brain and synapses talking to each other, and you sort of keep feeding in information from the front, and you reinforce the synapses that give you good predictions, and sort of winnow out the synapses that give you bad predictions. Genetic algorithms, you have sort of a string of, a rule that can be represented as a long string of genes, and then you start mutating that sequence, keep mutations that improve the accuracy. So in all these cases, you're actually assessing accuracy as you go along. So you have a training data set and a validation data set, and you just keep tweaking it, or the computer keeps tweaking it until it can't get any better. So it's like sophisticated trial and error. But the advantage of these is that they're flexible. You don't have to know a lot about what the functional forms are. You don't have to specify functional forms. The downside is it's hard to actually put any scientific information you have into the structure. So here's an example. So Maxent is now sort of the most popular tool that is used for species distribution models. And what's interesting about Maxent and a few of the other tools is that rather than creating pseudo absences, it uses what's called the background field. So it basically is